that omega is equal to, so relating alpha to omega. Why we have to relate at here A, right? Why? Because we are given that alpha A is equal to what? Is equal to 30 T to power half. So we know the relationship where we know that omega is equal to what? Omega is equal to dt. Might not be the right formula. Wait. Don't need this one. The formula that we need to know is that alpha is equal to d omega over dt. Right? So we are aware the omega alpha is equal to d omega and alpha. So when we have this, we can write that d omega is equal to alpha et. Okay. So from here, we know that when times is equal to 0, what are the values, right? So we know that we are going to integrate d omega. Let me write on do I have space? Yeah, I will write over here so I don't need to flip around and you can see, I can see. So we know that omega A, or we're going to integrate 0 omega A. We have d omega. And then we are going to integrate 0 to the time 5. Why 5? We are given that we are going to find the angular velocity at point D after 5 seconds. Okay, so alpha given to us, alpha is equal to what? 30 T power half dt. So when you integrate, you have omega 0 to omega A, and then this will be equal to 30 T multiplied by 3 over 2 divided by 3 over 2, limits from 0 to 5. So from here, we know that omega A is equal to let me calculate it. So 5 power of 3 over 2 times by 30 divided by 3 over 2 is equal to 1, 2. No, I think I pressed it. Is it 1250? Let me see. 5 power of 3 over 2 on 3 over 2 close bracket times by 30 divided by 3 over 2. 223.61 radians per second. Okay, 223. Then from here, we are going to apply this formula over here to find omega d. So we're going to determine what is our omega b. So we know that omega a or omega b, rb is equal to omega a, ra, right? So from here, I'm going to start on a new page. Now I want you to relax, okay? This problem is quite easy. It's the next two problems that will cause you a headache. So omega b and our RB is equal to 0.1. Our omega A is equal to 223.61. And now RA is equal to 0.025. So therefore, omega B will be equal to 223.61 times by 0.025 divided by 0.1, 55.9 radians per second. And omega B is equal to omega C. Why? They share the same shaft. Or we assume it to be a rigid body. So we're almost done. So we know that omega C, RC is equal to omega D, RD, right? So over here, we get 55.9. Let me zoom in a bit. I apologize. Multiplied by RC, which is equal to 0.04, is equal to omega D, and RD is equal to 0.1. So therefore, omega D will be equal to 55.9 times 0.04 divided by 0.1, 22.36 radians per second. Done. Okay. So much easier than mechanical vibration. Yes or no? Right? It's just a matter of plugging in formula. For now, okay? After this example, all hell will break loose. Even I have headache. Okay, I'm serious. Okay. But you guys have the mental stamina. You should be better than me. Okay. Right. Let's look at another example. Let's look at another example. Any questions regarding this example? You all like the way I break things down, yes or no? Makes sense? Okay. I know it's overwhelming. Even when I look at this initially, it is overwhelming. Okay. But don't let something overwhelming make you what? Give up. Are we clear? Okay, don't like, whoa, this is too much. I'm done. No, we don't do that. Okay. Students from McMaster, spirit of perseverance is second to none. Okay. Right. Let's look at example number 2. When I look at example number 2, the first thing on my mind is holy beep. Okay. Now there are more stuff. Have you all learned pulley yet? Have you all been taught pulley yet? Taught of, right? Nothing complicated with pulley, okay? Nothing complicated. Okay. Let's see what's given. So we are given that at A. Now, for this case, you don't need to draw a free body or simplify the diagram, because the diagram is as simple as it can be already. You agree or not? Right? You have to observe what is going on. So we are given that omega A at time 0 is equal to 3 radians per second. Okay. And it also tells us that in this case, the angular displacement is also equal to 0 and S is equal to 0. I start to panic. I'm like, huh? Where did this come from? Yes or no? Huh? Right? Look at the diagram. What do you see? S. Okay, that is S. So initially, when time is equal to 0, S is equal to 0, i.e. P is in contact with the what? With the floor. Be clear? Okay. So we are given that the angular acceleration alpha A is equal to 0.6 theta radians per second squared. So the angular acceleration is increasing over time. Okay, where theta given to us, theta is in what? Is in radians. Okay, determine the speed of the block when it has risen S is equal to 0.5. So we have to find when S is equal to 0.5 meter. Okay. What is VB? Okay. What is VB? So if you look at over here, this is the velocity of the block. Okay. Or velocity at point B. Now I want us to focus on the diagram now. Okay, so we are going to do some analysis. By looking at the diagram, we are going to do some analysis. And this analysis is important. Okay, this analysis. So this course, if you don't ask me how many percentage is analysis, I'll tell you about 30% is about analysis. Okay, in 3A03, 70% is analysis. Okay, so 2Q is going to be easier because the analysis example is less. So we know, right? We somehow the control is S, we know, has to be equal to 0.5 meters. Right? We know we have to determine the velocity D when S is equal to 0.5. Okay, so we are going to find VB when S is equal to 0.5 meters. Right? So we see what is given. So we know how, the first thing we have to ask ourselves, how is S, okay, related to theta D? Why theta D? Because the rope has been what? Y around pulley number D. Yes or no? Right? If pulley number D rotate this way, S distance will what? Will change. So from here, we know that S, okay, S, we need to relate, right? How to relate? So we know that S is equal to theta D, radius of D. And we are given that radius of D, we know that radius of D is equal to what? 75 millimeters. Okay, we know that the radius of D is 75 millimeters. Okay, and the good thing we know is S is equal to what? 0.5 meters. Now, any of you have issue with this formula at all? Anyone? Right? Because when you rotate the pulley, the rope get wound up and is related to the radius and theta D. And the rope is rigid, it's continuous. Okay, so when it rotates a certain angle, it covers a certain circumference. The circumference will shorten the what? Will shorten the rope, and your S distance will what? Will increase. Okay, remember that. Okay, so from here, we know that we can determine theta D. The next confusing part is this. Okay, the next confusing part is this. Now, before we talk about the next confusing part, we are going to write out what are the formulas that we can use. Okay, we're going to write out what are the formulas that we can use. Okay, so the formula we know about angular angular rotation, about fixed axis. Okay, so what do we know? We know that theta is the angular displacement. The next thing we know that omega is equal to d theta over dt, right? And the next one, we know that alpha is equal to d omega over dt. Okay. So these are the formulas that might be useful to us. Okay. And then we also know that velocity is equal to r omega. Do you all want me to provide these formulas in your formula sheet? Okay, provided. Because I understand there's an analysis component, I will provide all these formula. Okay, so I will provide all these formula. So from here, if we look at what we have, so given here, we can find theta d, right? From this formula, we can determine